Here's question 7, sketch. This is the function. We have to show this in the first instance. fx is a cubic. Okay, so we have to differentiate then. So here, g dashed x, it's a product, so it'll be u. Okay, well, we've got a lot of things here. I'm going to expand this bracket first. X squared minus x cubed. Differentiated. U. This is x squared minus x cubed, isn't it? E to the minus 2x. So let's just do that straight away. So it'll be u times the v dx, which is minus 2e to the minus 2x, plus v e to the minus 2x times du 2x minus 3x squared. Okay, which is equal to e to the minus 2x. We got minus 2x squared. We got an x cubed, so minus x cubed. Let's do that first. Minus 2x cubed rather. Oh, that'll be plus, because it's a double minus. Minus 2x squared minus another 3 is minus 5x squared. And then we got plus 2x. Close bracket. So there's f of x. Okay, let's just double check that. Minus 2x squared minus another 3. Plus and a minus is a minus. And then we've got minus times a minus is 2x cubes. Then at the end we've got a plus 2x, because that's a plus. So I think we're okay. So here f of x then is 2x cubed minus 5x squared plus 2x. And that was part A. Now back to the question. Hence find the range of g of x. Okay. So here's the curve. It's going to have a maximum and a minimum on the range, isn't it? So when does divide dx equal 0? And it says hence. So here g dashed x equals 0 when fx equals 0. So what value of x can we put in? What about 2? Looks promising, doesn't it? Because you'd get minus 16 minus 20. So that would, what about f minus 2? Minus f of 2, oh sorry, you'd get plus 16, wouldn't you? Because that's an equal. Oh, we're okay, we're back okay. F of 2 is 16 minus 20 plus 4, which equals 0. So x minus 2 is a factor. Okay, so what would we need to do now? I think the best thing to do is just divide it out, see what quadratic we get. So 2 is a factor, and actually when you look at the curve you can see that the 2, this might be the 2 or that might be the 2, don't know. So what's the other turning point? Well, I'm going to try and divide it out here. So x minus 2 divided into the cubic, 2x cubed. Oh, there's an x coming out as well, isn't there, of course? Oh, which I should have spotted. So it might be a bit easier than we thought. So we've got an x plus 2. When you take an x out from that, you get x 2x squared minus 5x plus 2. And then it's going to be x 2x x. Now, see, I don't quite get that. X minus 2 is a factor, which is good. Just as well it was a minus because it was getting problematic. So let's put a 2 in there and a minus 1 in there. Okay, so we get x equals 0, x equals a half, and x equals 2. So when x equals a half, g of x is equal to x squared is a quarter, times a half is an eighth, e to the minus an eighth, e to the minus 1, or 1 over 8e, and x equals 2, this is a half, is equal to, when x is 2 then, what do we get? 4 minus 4 e to the minus 4. Minus 4 over e, it looks like to me. E to the 4. Which seems a bit strange. Let's just do g of 2 again then. We get 4. 1 minus 2 is minus 1, that's minus 4. E to the minus 4. And x is 2. This doesn't look like it's way down there from the sketch, but maybe it is. So it's minus 4 e to the 4. This looks bigger than that, as far as, but that's just how it appears to me. So range then of g is minus 4 over e to the 4 up to 1 over 8e. It includes the points, so we put a square bracket. Okay, why does g minus 1 not exist? So let's go back to the sketch. Let's have a look here. Go back to our question. Bigger than or equal to 0. Qubit we found. State a reason why the function does not exist. Okay, well, it's not. If you try to turn that up, flip it upside down, this becoming the y-axis and that becoming the x-axis, you'd have a curve which looked like it would go like that, wouldn't it? It would go like that. So it would actually have more values than what you'd want. So it's not 1-to-1. That's what I can gather. Yeah, it's not 1-to-1. See these values here? Yeah, so it's not 1-to-1, I would say. G is not 1-to-1.